Greetings and welcome to all in attendance. I am Kyle McGuire representing Modern Wellbore Solutions. We express our gratitude for your valuable time to listen about our pioneering technology. We hold the conviction that our innovation marks a pivotal advancement in the ongoing shale resource revolution. Modern Wellbore Solutions was founded in 2015 with the goal of creating multilateral technology to reduce the cost and GHG intensity of developing deep basin assets. The deeper the well, the more costly and time-consuming the vertical section of the wellbore takes. We noticed there was a gap in multilateral technology for onshore, full-bore, high-pressure completions. We took our idea to 7 Generations, who was one of the largest Montney players at the time, and partnered with them to develop this tool. To ensure this technology was reliable prior to our first pilot, we designed and manufactured a one-of-a-kind test bench capable of creating the forces necessary to recreate downhole conditions. We rigorously tested each function of the tool to have a high degree of confidence prior to sending it to the field. We have worked closely with government granting agencies to showcase our technology and the benefits once commercial. Modern has been granted over $8 million to aid in our development. Our first pilot was successfully drilled in October 2020 in an abandoned well. The second pilot was run into a live well, which was successfully stimulated and put on production in June of 2022. The problem with stacked pay is how to access these reserves in the most cost-effective way. Currently, pad drilling and stimulation is the common technique. Each of these wells need a separate vertical bore to access pay. If a tool can be developed to withstand the completion techniques used for stacked pay, it would cut the cost and time associated with drilling a new vertical section. This is the technology solution Modern has developed. Creating a tool that has a full bore ID and frac pressure rated. The relevant information Modern requires to aid in a multilateral well design is the size, weight, and grade of the intermediate casing and liner. The directional survey for the initial lateral is required for optimal whipstock placement. This area needs to have low dogleg deviations to prevent issues during milling. The proposed depth and azimuth for the second lateral is needed to orient the whipstock and allow for a proper space out of the anchor to the liner hanger in the initial lateral. The benefits offered by our technology encompass a potential decrease of up to 40% in drilling and completion expenses. There is a reduction in the carbon footprint of a dual lateral well by eliminating a vertical segment and its surface equipment known to contribute to methane emissions. Furthermore, we leverage Canadian R&D tax rebates to bolster the company's financial runway through strategic investment. Our patented technology uses internal sleeves to create a pressure conduit to the lateral of your choice. These sleeves allow the pressure rating required without creating restrictions in ID. We are currently sized for the most common intermediate and liner casing sizes in the Canadian Deep Basin. With modifications to design and our current manufacturing capabilities, the junction can be upsized to fit with 9 5/8 or 10 3/4 inch intermediate casing, more common in Texas. Here we have an example of the different types of reservoirs we can access with a multilateral junction. The multilateral well can access stacked pay and reservoirs with thick net pay to improve recovery and reduce upfront capital costs. Here we have an animation of the installation of our multilateral junction tool after the first lateral is drilled, liner run, and hanger set using conventional methods.
Horizontal drilling and multi-stage fracturing has revolutionized the economics of oil and gas exploitation in North America. The industry continues to look to innovative technology and methods to increase recovery. One evolution has been to drill multilateral reservoir contact and production achieved. Return on investment is dramatically improved through shared vertical drilling, stimulation, artificial lift, equipping, and tie-in costs. Current challenges with completion of multilaterals include complex and costly operational procedures, lack of selective lateral access, burst collapse risks, as well as limitations on lower completion and artificial lift systems due to inside diameter restrictions. To address these challenges, Modern Wellbore Solutions has designed the world's first full-bore, cased-hole, pressure-rated multilateral junction assembly. The whipstock assembly includes a lead mill, string mill, follow mill, retrievable whipstock and equalization sub, junction body and sleeve, expansion joint, tri-directional anchor, and liner hanger top-landed seal assembly. After drilling of the lower lateral and installation of liner along with liner hanger, the whipstock assembly is run in hole and oriented via measurement while drilling, or MWD. The liner top landed seal assembly is connected into the liner hanger packer of the lower lateral completion string. Once a positive pressure test has been confirmed, downward mechanical motion is applied to exert compressive force onto the shear ring within the expansion joint. The string continues to move downward where it lands out on top of the anchor, which shears and engages the slips into the intermediate casing. To initiate drilling of the upper lateral, alternating tension and compression is applied to the drill string until the bolt connecting the casing mill bit to the whipstock shears. The casing window is then milled with the lead, string, and follow mills to ensure proper gauge hole is executed. Using today's current window milling technology ensures the rat hole trajectory is in line with the auto alignment equipment used during the mating procedure of leg 1 and leg 2. Once the rat hole is complete, the lead, string, and follow mills are pulled out of hole. Directional drilling tools are picked up and the next lateral is drilled. After the upper lateral is drilled and reamed, a whipstock retrieval tool is run in hole on drill string and latched into the whipstock via a key and keyhole connection. Upward motion on the retrieval tool shears the pins in the equalization port, as well as the bottom of the expansion joint, and pulls the junction body into the original whipstock position, leaving only one possible path for the second liner to travel. Once the expansion joint is fully extended and locked into its upward position, a collet in the junction body collapses to release the whipstock and equalization sub so they can be retrieved from the wellbore. The lower portion of the junction body rail guide system is now aligned with the casing window. The second completion string, including the mating sub, is then run into the upper lateral. A bullnose on the bottom of the liner is deflected off the junction body and into the upper lateral. To mate the upper and lower junction, the male portion of the auto alignment system is ran on the upper junction, which guides itself into the female portion, which is awaiting on the lower junction. Sufficient compression is applied to top of junction and below the upper liner hanger, at which point cement is pumped throughout the annulus in leg 2, and the upper liner hanger is set. The tieback string is run in hole and the drilling rig is moved off well site. A frac crew is then moved on site for stimulation operations. The internal sleeve in the mating sub is initially positioned to enable stimulation of the upper lateral, as there is a conduit from TD to surface in lateral 2. Increasing hydraulic pressure from surface opens the hydraulic toe port in the upper lateral. Leg 2 can now be stimulated. After stimulation operations are complete, wireline is ran into the wellbore with the dual-anchored stroking tool, coupled with lateral selection technology, and placed across the upper lateral sleeve and sleeve housing. The upper sleeve is shifted downward to allow room for the lower sleeve to shift upward. The lateral intervention tool is pulled up above the converging area. rotated 180 degrees, and lowered into the lower lateral while placed across the lower sleeve and sleeve housing. At this point, the lower sleeve is shifted up into position to create a conduit from TD to surface in lateral 1 and is now ready for stimulation. Once the toe valve in leg 1 has been hydraulically opened. Once stimulation is complete, the mill-out assembly is picked up and ran in whole, coupled with the E-coil ACOS steerable system, and leg 1 is milled out. Once TD'd with milling assembly, the system is pulled back and slips are engaged into sleeve 1. The sleeve is shifted down to allow production from both laterals. The milling assembly is pulled up past the converging area and adjusted to run into leg 2, at which point debris and plugs are milled out of leg 2. Modern Wellbore Solutions is dedicated to the advancement of multilateral wells with continuous innovation of cost and time-efficient drilling and completion.
I will highlight the main steps in the drilling operation. Step 1 is to run in the whipstock and lower junction BHA into the liner hanger of lateral 1 and set the anchor with compressive force. Step 2 is to shear the lead mill bolt and start to mill the rat hole. Once the dress mill makes it 3 feet past the bottom of the whipstock face, pull out of hole and run in directional to drill the second lateral. Step 3 is to retrieve the whipstock, which shears the expansion joint pins and allows the lower junction to align with the window. At this point, the upper junction is run in, which auto-orients with the lower junction via the mule shoe. The upper junction will shoulder on the lower junction, and the lateral 2 liner hanger is set. Once the drilling rig is released, the stimulation of the upper junction will start with the upper lateral. When the upper junction is lowered downhole, this isolation sleeve is in the closed position, so the frac starts opposite of the lateral drilling. Once the upper lateral is stimulated, the isolation sleeve will be mechanically shifted with tubing, coil, or wireline stroker tool. The upper sleeve is shifted down, and the packer or gripping tool is then run into the lower isolation sleeve and pulled up hole into the closed position. The lower leg can now be fracked. We successfully tested a wireline stroker tool on our bench to give the operator multiple completion options for switching laterals via shifting sleeves. After the isolation sleeve is shifted downward, the tool is run into the lower isolation sleeve and shifted upwards into the closed position. There is now a pressure-rated conduit from surface to the lower lateral or the first lateral drilled. Our technology is cost-effective because we have minimized the number of trips and time it takes to drill and complete a multilateral well. There are no custom completion tools required as the internal bore is the same as standard casing. The potential to add additional junctions or stack them will further reduce the cost of the well per lateral. Our technology can work with coil shift sleeves, plug and perf, and ball drop. I extend my gratitude to each one of you for your presence here today. A special thank you goes out to Darcy Partners for selecting us as the presenters of our technology before you.